Hello everyone. Here we are now with goal number 5, which deals with the quadratic formula. A quadratic, remember, is a trinomial that has a 2 for its degree, or a square. So what you have probably seen in the past is that with the quadratic formula, when you have ax squared plus bx plus c, this is a quadratic written in standard form. Given that it's in standard form, we could say that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Some people use mnemonic devices to try to remember it. Remember in class we did ours as pop goes the weasel. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to take this quadratic formula and use it to solve our quadratics. Okay? So rule number 1, get it into standard form. So when we have this example, 2n squared minus n minus 4 is equal to 2. We're going to move the 2 over, and we're going to get everything equal to 0. From here, we need to know what is the a value, the b value, and the c value in our problem. In this case, a is 2, b is negative 1, and c is equal to negative 6. Use these values within our quadratic formula. So starting off, we're going to have x equals opposite of b. Since b is negative 1, we're going to have positive 1 plus or minus the square root of b squared, which is going to be negative 1 squared, minus 4 times a times c all over 2 times a, which is 2 times 2. Again, that's just simple substitution of putting our a, b, and c values into the problem. Now that we've done this, let's go through and start simplifying all the parts. Let's start with the inside. We have 1 plus or minus the square root of, this will be 1 plus 4 times 2 is 8, and 8 times 6 is 48, over 2 times 2, which is 4. That then will give me x equals 1 plus or minus the square root of 49 all over 4. Let's carry this over here now. So we are now going to have, when we simplify this, x equals 1 plus or minus square root of 49 from over here is just 7 all over 4. Now this plus or minus means that we have two separate problems. That means our first problem is going to be x equals 1 plus 7 divided by 4. And the other one is going to be x equals 1 minus 7 divided by 4. So if we solve each one of these, we get 8 over 4, which is equal to 2. That's our first answer. 1 minus 7, which is equal to negative 6 over 4, which is negative 3 over 2 if we reduced it. And remember, no decimals. Okay? This is an easy example because everything worked out very well. Let's take a look at a medium example. Again, if you're comfortable with it, pause it, try the video or try the problem. So let's start off first getting this into standard form. Take the 6x and let's move it over so it's all equal to 0. So we have minus 6x and then minus 11 is equal to 0. Our a value in this is 9, b value is negative 6, c value is negative 11. We're just going to take these values and substitute them into our quadratic formula. So we have x equals 6 plus or minus the square root of, because that's the opposite of b, by the way, plus or minus the square root of b squared, which is negative 6 squared, minus 4 times a times c, all over 2 times a, which is 2 times 9. This is x equals 6 plus or minus, remember now we're just going to simplify the inside. So this will be 36 minus, and we're going to go 4 times 9 times 11, which is 396, and 2 negatives make this a positive, all over 18. All right, let's go on to our next step. Carry this over here. We're going to get x equals 6 plus or minus the square root of, and we're going to go 396 plus 36. And we're going to have 432 over 18. Okay, next we have to try to simplify this radical if we can, because there's no, square root of 432 does not equal a nice round number. It's 20.785. So we have to figure out what's a perfect square that is a factor of 432. So if we go 432 divided by, and just try some of the problems, okay, you'll see that 144 and 3 are the factors that we would use. That means that we're going to have x equals 6 plus or minus 12, because the square root of 144 is 12. 12 square root of 3 over 18. And then we have one final step. When we end up with a simplified radical on the top here, we have to see if we could reduce each one of these. Okay. So when we look at 6, 12, and 18, we want to know, do they have anything in common that they could all be divided by? We don't simplify this if only two of them, like if it was just 6 and 18, we wouldn't just simplify it. It's got to be all three of them are the same. So 6, 12, and 18 have a 6 in common. If I divide each of these by 6, 6 divided by 6 will be 1, 12 divided by 6 will be 2, and 18 divided by 6 will be 3. And these are our two answers. All right, and we have one more problem. That was the easy, the medium, so let's try now a difficult one. So we have 8a squared plus 6a equals negative 5. Pause it and go ahead and try it on your own, and then let's check our work. Okay, so now that this is equal to, or let's get this first in a standard form, so we got to make it all equal to 0. That means we're going to have 8a squared plus 6a plus 5 is equal to 0. If we go through and start actually taking the values, we get that a is equal to 8, b is equal to 6, and c is equal to 5. Use these a, b, and c values to put it into the quadratic formula. So we get x is equal to opposite of b, which is going to be negative 6, plus or minus the square root of b squared, which will be 6 squared, minus 4 times a times c, all over 2 times a, which is 2 times 8. Simplify each of these, negative 6 plus or minus the square root of, and this will be 36 minus, let's see here, 4 times 8 times 5, which is 160, all over 16. Simplify from here, x is going to equal negative 6 plus or minus the square root of. And this will be 36 minus 160, which is going to be negative 124, all over 16. So we simplified as far as we could here. Now let's look at this radical. Negative 124. All right, we know we can't have this negative here, and we know the square root of a negative is just going to make this imaginary. But what about this 124? Does 124 have any perfect squares as its factors? The only perfect squares that are factors of 124 are 4 and 31. So if we go through and put this in, let's move it up here, we get x equals negative 6 plus or minus, and the square root of 124 will be negative 4 times 31 all over 16. If we simplify that square root of negative 4, we're going to have plus or minus 2i square root of 31 over 16. And now let's again look at each one of these three parts. We have a 6, a 2, and a 16. They're all outside of our square root. They all share 2 as a common factor. So if we divide each one of these by 2, we end up with negative 3 plus or minus 2 divided by 2 is just 1. So 1i square root of 31 over 16 divided by 2, which is 8. I hope this helped. Please let me know if you have any further questions. See me during seminar if you want to do some more practice problems. Otherwise, that is it for today. Rosenwald out.